hero of racing. American columnist and humorist Dave Barry once said that auto racing is boring unless you have a car traveling 172 miles per hour upside down. Now granted, at those speeds, even the smallest fender bender could result in a jaw-dropping catastrophe. Now, race car fans would argue that there's more to the excitement of racing than just the spectacular crashes. And evidently, their views are catching on. Auto racing, especially NASCAR, has one of the largest growing fan bases in all of sports.
You cannot be a racing fan and not know what the word speed means, although you may often misuse it by confusing it with a related word, velocity. The two are actually slightly different. Speed is a calculation of how much distance one could cover over a given period of time, such as how many miles you can cover in 1 hour, miles per hour. Velocity is pretty much the same thing, but includes movement and direction as well. In other words, velocity is speed with direction. You have also probably used the term acceleration before. Acceleration is related to velocity in that acceleration is a measure of how much your velocity changes over a given period of time. When you hit the gas pedal, you are accelerating because you can see the speedometer needle rising, which means that your velocity is changing as time goes on.
So what if you're a race fan and you want to keep track of the average velocity of your favorite race car driver as he or she makes his way around the track? Well, actually, it's pretty easy to do. All that you need is a stopwatch, and you'll need to know the distance around this particular track. Most NASCAR tracks, for example, are about 1 to 2 miles around. You'll also might need to bring a calculator if you can't do math very well in your head. Then, pick a spot to start timing the driver and start the stopwatch. Stop the time when the driver returns to that same spot. Then use the equation for velocity.
The delta sign means change in. Plug in the distance for the track for delta D, since that was the change in the driver's distance. In other words, how far he or she went. And plug in your stopwatch reading for delta T, since that was how much time elapsed. In other words, how long it took the driver to go that far. Since it is probably easiest for you to think of velocity in terms of miles per hour, you will want to convert your stopwatch reading into hours. For review on how to convert units, review the appropriate chapter in your textbook. As an example, let's say your favorite driver completed a full lap in 42.35 seconds. And let's say that the distance around the track was 2 miles. If we divide these numbers, we will get an answer in miles per second. Since we are used to measuring velocity in miles per hour, we need to convert seconds to hours. In this lab, you will be exploring the concept of velocity a bit further. For part A of the lab, you will use paper, a stopwatch, a marker, and a self-propelled toy to measure velocity over a flat surface. One person with a stopwatch will call out equal time intervals that are manageable but result in at least 5 or 6 data points for the total trip. This will depend on the toy you are using and how fast it goes, so you will have to try a few practice runs. Another person will mark the position of the toy when each time interval is called. For example, if you decide to measure in 3-second intervals, you would mark the position of the toy after every 3 seconds, being sure to mark the starting point as well. To avoid interfering with the motion of the toy, mark the position from behind each time. This also means that the starting position should be marked from behind. You will then need to measure the intervals between the time marks, record your data, and make a graph. Be sure to refer to the lab procedure for information regarding analysis of this data. Part B of this lab is similar to Part A, except you will now time the toy while it is moving up an inclined ramp. The ramp will vary in height at the top and is at least 1 meter or about 1 yard long. You will also record and graph this data. Part C of this lab explores what happens when velocity changes or is not constant.
This has to do with acceleration. More specifically, in this case, the acceleration corresponding to a force that we call gravity. Gravity is actually a force that causes objects to fall in the sense that their velocity becomes greater and greater the closer they get to the Earth. If you hold a ball in the air on top of a tall building, it starts with a velocity of 0. But when you drop it, that velocity changes by a certain rate that we call gravity. This corresponds to an increase of nearly 10 meters per second for every second. In other words, the velocity increases somewhere around 22 miles per hour every second. In Part C of this lab, you will roll a ball down a ramp, which gives you more time to measure than if you dropped it straight down in the air. You will build a setup similar to this one. Be sure to consult your lab procedure for the specifications. You release the ball from 6 different places along this ramp and time how long it takes to reach the bottom. You will then record and graph this data. Hopefully, you will see that the more time a ball is given to accelerate, the more its velocity can increase.